Good evening, everyone. I, Yash Vastava, on behalf of Creators Garage and Computer Club, welcome you to the day 5 of the Ultimate DSA Bootcamp. Our instructor for today is Miss Saniya Agrawal, and the topic for today is graphs. Ma'am, you may go ahead.
Hello everyone. Actually, the topic for today is dynamic programming. Graph was covered in the yesterday's session. So let's start the session. So dynamic programming. Dynamic programming is basically an optimization over recursion. Whenever we have a problem with the recursion, we can optimize it because generally recursion gives us exponential time complexity. So dynamic programming is a technique to optimize our recursion functions. So let's understand what is recursion. Recursion is the process in which function call itself directly or indirectly. Like example, this is a factorial function where we find n into n minus 1. Is my screen not visible? Can moderator tell me?
Yes, ma'am. Yes, ma'am. Your screen is not visible.
Okay, okay. Uh, is my presentation visible?
Yes, ma'am. Now it's visible.
So yes, dynamic programming. So let's again see what it is. So recursion is a function which directly call itself again and again to find the solution. So factorial is a function in which we calculate from n to n minus 1 and we product all of these. So this is a simple function where factorial we call factorial of n and then multiply n into factorial of n minus 1. Suppose our n is 5. So we will multiply n 5 into 4 factorial of 4. So factorial of 5 is basically 5 into factorial of 4. And recursively, we can say that factorial of 4 will give us 4 into factorial as 4. So 5 factorial will be 5 into factorial of 4. So this is a recursion, but we need to optimize many problems because it can create exponential time complexity. So let's move on to the next slide. So there are two ways to solve any question with the DP. There are two ways: tabulation and memoization. So in the tabulation method is also known as bottom-up method, and memoization method is also known as top-down method. So let's understand this by our basic understanding. So what is bottom up? So like in general language, let me see this statement. I will study the theory of DP. Then I will practice some problems on classic DP and then I will master DP. So basically we start from the basics, from learning to practice problems and then becoming a master. But in the top down, we say from like top is mastering DP. So we say master DP and then we say to master DP I would have to practice dynamic problems and for which I have to study some theory of DP. So in bottom up we go from bottom, from the basics to the highest point. From top down we go from the top to the basics. So let's understand it with the form of code. Like we need to calculate factorial. So we will first calculate the base. For the bottom up, we will first calculate the basics and the base condition. So dp of 0, like 0 factorial will be 1. So dp of I will be dp of I minus 1 into I. Why? Because dp of 1 will be dp of 0 into 1. So it will give factorial of 1 as 1 into 1. Then we will calculate dp of 2, which will be dp of 1 into 2. So which will give us 1 into 2, which will give, so factorial of 2 will be 2. Then factorial of 3. So we are going from the basics, from dp of 0, that is 0 factorial, to 1 factorial, to 2 factorial, and so on till we find the nth. Suppose I have to find for 5 factorial. So I will start from 0, then 1, then 2, then 3, and then 4 and 5. So from basics to like the final solution we are going. So this is the bottom method, also known as tabulation method, because this is a form of table, because this is an array. So like for at the index 0, we will store dp of 0. At the index 1, it will be factorial of 1. At the index 2 will be factorial of 2, and so on. So this is a form of table, because we are storing the values into the table and then reusing it again. Because for calculating dp of 1, we are taking dp of 0 and then multiplying the I value. Now the second method, memoization, which is also known as top-down approach. So we are taking the same problem, calculating the factorial. Now in this, we will go from top to the bottom condition. So our top condition is factorial of n, and the base condition is factorial of 0. So first we will go from n factorial to the 0. But how is it possible? So we will write a recursive code in which, suppose my x is 3. So I will check if x is 0. No, this is the base condition for 0, because in 0 we already know the answer. And we are initializing an array. This is an array in which we are storing all the values from top to the bottom. So first we will calculate we will call this function for dp of 3, which will call a recursive function 3 into solve of 2, because x minus 1. So then again, firstly we will call solve of 3, solve of 2, solve of 1, and then finally solve of 0, which will return 1. So there will be no more recursive calls. So initially when I call factorial 3, solve 3, so dp of 3 will store the value of x into factorial. Solve of 2 will store the factorial of 2. So we will store 3 into 2. So and if it is already calculated, this will fulfill the condition if the dp of x is already calculated. Suppose we are doing multiple calculations and we already have the value of dp of 2, and we do not need to call again and again for calculating factorial of 2. So we will check if dp of 2 is not equal to 1. We will initialize the dp array to -1, which will indicate that if it is -1, then it is not calculated before. If it is not -1, then the value we have assigned as dp of x will be x into solve of x minus 1. As no value will be -1, so it will help to check the condition if it is pre-calculated or not. Now let's take an example, Fibonacci series. It is a very famous series, so let's understand what basically it is. So it gives us any term in the Fibonacci series is defined as nth term will be n minus 1th term plus n minus 2nd term. So let's see with an example. If first term is 0, second term is 1, then a third term will be the addition of these two terms, which will be 0 plus 1, which will give us 1. Then we need to calculate this term. We can calculate by adding the previous two terms. So it will give us 2. For this term, we can add the previous two, 1 plus 2, which will give us 3, and so on, like 2 plus 3 will give us 5, and so on. It is an infinite series. So in this, by default, it is given f of 0 is 0 and f of 1 is 1. So first term is 1 and we are taking 0th term because we need to calculate the second term by the use of these two terms. So our 0 term is 0, first term is 1. So we can calculate second term from this equation. That will be f of 2 will give us f of 1 plus f of 0. And we have f of 1 as 1, f of 0 as 0. So from this equation, we can calculate all the terms if we have the first two terms. So this is the Fibonacci series. So let's understand it with the help of code. So first, let's see the recursive code, and then we will move to the dynamic programming code. In dynamic programming, if you know the recursive code, then it is very easy to convert it into the DP. So initially, you need to understand how the recursive code works, and then DP is not such a big thing if you understand the question, and if you can write the recursive code, then DP becomes very easy. So as we have seen, Fibonacci of 5 will be Fibonacci of 4 plus Fibonacci of 3. And then we will recursively calculate Fibonacci of 4 because we do not have the value of Fibonacci of 4. So which will be Fibonacci of 3 plus Fibonacci of 2. Then Fibonacci of 3 will be Fibonacci of 2 and Fibonacci of 1. And so on. This is the structure of a tree, if you can see. So we are calculating Fibonacci of 3, this whole thing again here and again here. So our time complexity increases because we are calculating the one thing again and again. Like Fibonacci of 2 is calculated one time here, second time here, and third time here. So think it was just a question of Fibonacci of fifth term, and if it increases, it will give us large complexity and it will be exponential. So let's understand how we can write the code for this. So in the recursive, we know if n is less than 1. So we know the value if n is less than 1. If it is 0, n is 0, then we know if n is 0, then the Fibonacci is also 0 Fibonacci term. And like we have seen in the previous slide, if n is 0, then the term is also 0. If n is 1, then the term is 1. So we can define the base condition because we do not have negative values. So we have to define the base condition. So if n is less than or equal to 1, we already know the term. So we will return n, which will be if n0, then 0, if n1, then 1. Else, we will calculate, if it is 2, then we will calculate Fibonacci of n minus 1, which will be 2 minus 1, 1, and n minus 2, which will be 2 minus 2, 0. So Fibonacci of 2 will be, we will recursively call the function for Fibonacci of 1 and Fibonacci of 2. In suppose we call Fibonacci of 1. So again, this function will be called if n is less than equal to 1. So our condition is satisfied. So we will return 1. So this function call will return the value 1. And for Fibonacci of n minus 2, that means Fibonacci of 0 will call the function. And again, it meets the base condition. So it will return 1. So Fibonacci of 2 will eventually return 1 plus 0. So this recursively we call again and again. So if you can notice the pattern, like we are doing this tree, we are traversing this tree. So n minus 1 we call 4 and 3. For n minus 2, which we call the function for 3, here also we are having Fibonacci of 3 and here also we are having Fibonacci of 3. So we need to optimize this. And for the time complexity will be t of n minus 1 plus t of n minus 2 because we are calling at n. we are calling for n minus 1 and n minus 2 both. So now let's understand with the help of DP. How can we optimize it so that our time complexity do not go exponential and our code is optimized? So we have to avoid the repetitive work we are doing. Like we are calculating Fibonacci of 3 again and again. So we let's think what can we do. So we can store the value which we have calculated in an array. Just like we can create an array just like we did in factorial. For 0, we were storing the value in the array and using it again later. For 1, similarly. So we will here also create an array. The array name is f, and store we will store the values as f of 0 as 0, because our 0 term we know that it is 0, and f of 1 as 1. Now, storing in an array will help us reduce the time complexity, because for suppose like for f of 2, we are not again calling for any function. We are just fetching the values from an array, which is a O of 1 time complexity operation. So it will not go exponential, and we are just running a loop from 2 to n, which will give us the time complexity of O of n, and thus our code is optimized, and we are not again and again, suppose like for we will first calculate Fibonacci of 0 and 1. Then we will add these two and store in the array the value of Fibonacci of 2. Then for Fibonacci of 3, we will add previous two terms and store in an array. So our array will just traverse for a single time from till n, which will give us time complexity of n. As we are using an extra array, so our space complexity will be O of n. So can we optimize it? Like, can we do it without using any space? So yes, there is a way. So we just need the last two terms to find the next term. So why don't we take just two variables to store the previous two terms, so that we do not need to create an whole array, and our space complexity will reduce from big O of n to big O of 1. So our first, so in A value, we will store the first term. In the B variable, we will store the second term. And in the C is a temporary variable, which will store the uh, sum of the previous two terms to calculate the next term. So we write the base condition, because we know if n is 1, n is 0, then we have to return A, which is 0, as Fibonacci of 0 is 0. And for we will calculate for and also here a condition will come: if n equals to 1, then we will return B. Then for Fibonacci of 2 and onwards, we will run a loop where we will calculate the sum of the previous two terms. The n minus second term will be stored in A, and n minus 1 term will be stored in B. So for n equals to 2, we have A as 0 and B as 1. So we'll get C as 1. So then we will assign the values like 0, 1 and 1. We have the values, first three values. This is C, this is A, and the middle term is B. So now for the next iteration, we have to store this as A and this as B, this term as B. So we will assign A as B. So our A will hold the value of this term, and our B will store the value of this term. So now our A and B are 1 and 1 respectively. Now for I equal to 3, we have A as 1, B as 1. So C will be 2. And C is 2, A and B are 1 each. So now we need to assign them. Uh, again need to reassign the values of A and B. So A will hold the value at which the B term has. So A will should hold the value 1 and B should hold the value 2. So we are doing A equals to B. A will hold the B value and B equals to C, which will store the latest term. So now, like if my loop gets over, I need to find the fourth term because this is 0, 1, 2, and third term, sorry. So we will, so our B is pointing at 2. So we'll return B because B will contain the last value of the term from the loop. So our space is optimized because we are just using two variables instead of an array. So it gives us time complexity as O of n and space complexity as O of 1. So we have seen how from exponential time complexity, we have reduced the time complexity of to O of n and space complexity to O of n. And then we again optimized it to time complexity of O of n and space complexity of O of 1. So this is the beauty of dynamic programming. It helps to convert exponential time complexity problems to just linear problems, and it optimizes a solution. So let's take another problem, tiling problem. So in this problem, we have a board and a tile. So a board is of size 2 cross n. Row are fixed. There will be two rows only, and the number of columns can vary to n. So, and we have to fill this board with the help of tiles. So our tiles is of size 2 cross 1, like this. So we can place a tile in this fashion or in the straight fashion also, like this. And we need to find the number of ways in which we can fill this board with the help of these tiles. We can, so let's understand with this with the help of diagram. So our case one is placing the tile in the vertical way, and the second case is to place the tile in the horizontal way. If we place the tile in the horizontal way, so to fill these two cells, we should have a we should place the tile in this fashion only, because we can't place the tile in this fashion if we have already placed a tile in this way. So there are two ways to fill, like one is vertically and another is if horizontally, then the upper two cells should also be placed horizontally. So let's understand how can we find the number of ways. So let's think it with the help of recursion. So if this length is n, so if we place a tile vertically, like in this way, then we have n minus 1 columns to fill. So this is a single way because we already fixed that the last column will be placed with a vertical tile. So the ways to place this tile in this fashion will be count of n minus 1, because our function is a recursive function. We are calling for n times 2 cross n. Then we know if we place a tile in this way, then the ways will be count of n minus 1. But if we place a tile in this way, then we have another another arrangement. So so this is a single way to place a tile because horizontally and horizontally. So we will have n minus 2 columns. So our ways will be n minus 2. So we have two cases, one where we place horizontally and another where we place vertically and then horizontally. So it gives us ways as count of n minus 1. We will again call the function to n minus 1. And here we will call the function from a function for n minus 2. And these are the both possible cases. So we will add these cases. So our solution will be count of n will be count of n minus 1 plus count of n minus 2. So we have just studied the same equation in the Fibonacci series. So basically the solution to this problem is Fibonacci series only. As if we have suppose 2 cross 1 only. So we just have one way to place it because we just can place it vertically. So Fibonacci or the count to place the ways are same. If n is 1, then 1. If n is 2, that means 2 cross 2, we have the both sides. So we can place a tile in two ways. One is like this and this, and another is this and this. So there are two ways. In first case, both the tiles are horizontal, and in the second case, both the tiles are vertical. So we in the Fibonacci of 2 was also 2. So we get this like if n is 1, then we have number of ways as 1. If n is 2, so we saw there are two ways. So similarly, we will call for if n is greater than 1 or 2, then it will give us, as we found, we will call the function for n minus 1 and then the number of for n minus 2. So this is the function, and it's very important to write base condition in the function, else it will go to infinite loop. So we know the two base conditions that if n is 1, then we can only place in one way, and if n is 2, we can place the tiles in two ways only. So with the help of these two base conditions, we can calculate all of these. So suppose if n is 3, so we'll get number of ways of 3 minus 1, which is 2, and 3 minus 2, which is 1. So number of ways to place on a 2 cross 1 board and 2 cross 2 board. So which will be 1 plus 2. So we will get 3. This is a recursive function, and we just need to understand this equation. This equation will write code, and never forget to write the base condition whenever you write a recursive. So let's see the how we can do it with the help of DP. It is just as same as Fibonacci series as we did because the equation is also the same. So we know f of 1 is 1 and f of 2 is 2 as discussed. Now for from I equal to 3 to till n, we will add just the previous two terms. Here also our time complexity will be O of n, and similarly as we did in the Fibonacci series, we can optimize the space just by using. So here also in this slide, we can just use two variables to store just like we did a and b. So we will just add previous two terms a plus b, which will be the next term. So basically, you need to understand what the problem is saying. The code is very easy. We just learned Fibonacci, and if we found that uh, the solution to this question is count of n minus 1 plus count of n minus 2, then it is very easy to write the code. So every time just understand the question, you can break the question. Like for n, we did placed at a and reduce the problem to n minus 1. Here we place the tile in this way and we found the count of n minus 2. So always in recursion, the value of the parameters should always decrease. If it will increase, it will go in infinite loop. So we can see in the both these functions, we always reduce the n. So firstly it was n, then we reduced to n minus 1 and n minus 2. So always in recursion, the parameters should decrease and base conditions should always be properly defined. So let's move on to the next question. So we need to count the number of ways to reach the nth stair using step 1, 2, or 3. There is a staircase, and we can only make jumps as to distance 1, 2, or 3. Suppose I am at the first step, then I can only jump to second, third, or the fourth, because this is at distance 1, this is at distance 2, and this is at distance 3. So maximum I can jump to three stairs. So if on this step, I can jump to maximum 3 stairs. So we need to find the number of ways in which we can go to the nth stair using only these three kind of jumps. So let's understand it with the help of example. So if our input is 4, so that means we have 4 stairs, and we need to find in how many ways we can reach the fourth stair from the bottom stair. So we can jump 1, 1 each time. We can jump 1, 2, and then 1, 2, 1, 1, 1, 1, 2. Basically, the sum of the steps should be 4, because we need to reach the fourth stair. So these are the different ways, which are 7 ways. Now, if the number of stairs are 3, so I can take 1 step each time, 1 and then 2, 2 and then 1, and 3 steps at a time, because we can take maximum of 3 steps. So it will give me 4 ways to reach the third stair. So basically, we need to find the number of ways to reach the end stair from the bottom. So if you can see the pattern, like for the just let's see the recursive code. We are finding to reach the n minus 3. Suppose I need to reach the 10th floor, and I have to calculate, because I can just jump maximum of 3. So I will jump to the 10th step with the help from 9th step, 8th step, or 7th. From 6th, I cannot directly jump to the 10th, because it has difference of 4. So I will just calculate in how many ways I can reach the n minus 1th step. That means from the 9th step, or from the there are how many ways are there to reach to the 8th step, or how many ways are there to reach the 7th step. And if we add all these, so if we reach the 7th step, then we just can jump 3 steps. So it will give us the number of ways if it directly jump from the 7th to the 10th step. Find step n minus 2 will give us uh, will give us like from the 8th step to the 10th step, if we jump directly from 8 to 10. So we will again add n minus 2 recursively, and similarly n minus 3. So our recursive function becomes we just need to add the previous 3 terms, and the base condition, we have three like recursive calls and 3 different values of n. So we should have 3 base values. So if n is 1, if we call n equal to 1, then there is only one way. If we have to reach the 0th step, there is only one way. And if we have to reach the 2nd step, we have 2 ways. First, we can jump from 0 to 1, and then 1 to 2, or directly from 0 to 2. So there are 2 ways. So this is our function. And as we are calling 3 times the function, so it will become 3 to the power n time complexity, which will be exponential. So any doubts till now? Moderators, can you please convey if there are any doubts? Okay, I think there are no doubts. Are there any doubts, moderators?
Currently, no doubts.
Okay. Everybody, please feel free to ask doubt because this is not a easy topic. If any doubts, please ask. I will be glad to clear your doubts. So let's see what we are calling in this function. So if we have to find for 4, we will find for n minus 3, which will be the for from the one step. We will call the function for n minus 2, which will give us value 2, and n minus 1, which will give us value 3. So these are the three ways. From that means from the first step we can directly jump to the fourth step, which is a way to directly, if we take, we already defined that we are taking a 3-step jump. For this f of 2, we are assuming that we are taking from the second step directly a jump of 2 length. And if we are on the position 3, so we are assuming that we are directly taking a 1-step jump. So these are the three ways in which we will jump to the fourth step. So we'll calculate for f of 1, f of 2, and f of 3. So f of 1 we already know it is 1. F of 2 is already known as 2 because we have defined the base condition for 0 as 1, 1 as 1, and 2 as 2. So for 1 we already have 1. So it will not again call any recursive function from this equation. It will directly return from here. So for 1, 2, it will directly return. For f of 3, it will call 3 recursive functions again because it do not satisfy any of these conditions. So we will return find step of n minus 3, n minus 2, and n minus 1, and sum all of these. So n minus 3 0, n minus 2 1, n minus 1 2. So all these three are base conditions. So we have 1, 1, and 2. So we will add all these. So 1 f of 3 will be 1 plus 1 plus 2, which will be 4. So this function will return 4 to the f of 4 function call. This will return 2 and this will return 1. So we'll add all these three to give us plus 2 plus 4. It will be 7 as we saw in the first slide. So let's see our approach with the help of DP. How we can solve this problem and optimize the complexity as it was exponential and a huge time complexity of 3 to the power n. So is there any way to optimize a solution? So we can see a pattern that we are adding the previous three terms. Like for f of 4, we are adding f of 1 plus f of 2 plus f of 3. So we can store the values in an array and then use the previous calculated values to find the next terms. So just like we did in Fibonacci series, we took an array, defined the base, values, and then we will run the function and use the previously calculated values. So which will give us the time complexity of O of n and optimize the solution. So as we know, for zero value uh, we have number of ways as 1. To reach the stair 1, we have number of ways as 2, and to reach second we have 2 ways. So after, if we have these three values, we can calculate it all the values in just n time complexity, because we'll just run a loop till n and just use the previously calculated values and do not call any functions call inside this. So we are just using O of 1 time complexity to calculate any term. So we are calculating n terms from 0 to n. So it will give us time complexity as O of n. I hope till here it is clear to everybody. If any doubts, please feel free to ask questions. So Moderators, if there are any doubts, please convey to me. Otherwise, I will move on to the next question.
Sure, ma'am.
So let's move on to the next question. So now the question is binomial coefficient. So I think everybody of you have studied about binomial coefficient. So it is if you have to calculate NCK. So we have learned this equation, which will be n minus 1 C K minus 1 plus n minus 1 C K. So if we add these two terms, we get the value of NCK. So have you ever thought like how can we calculate this with the help of code? So uh, like what you will do, you will write a recursive code to calculate n minus 1, then n minus 1 k minus 1 term, then n minus 1 comma k. So this will give us again that problem where we are calculating same term again and again, just like if you have to calculate 5c2. So we will call the functions n minus 1, so 5 minus 1 is 4, and k minus 1, so 4 comma 1. And the second term will which we will the second function call which we will be having will be n minus 1 comma k, so 4 comma 2. And these functions call will go on, and we can see like c comma 1 is called two times. C like c of 2 comma 1 is calculated three times. Suppose if we have a huge tree, so many terms are calculated multiple times, which is unnecessary. Like we did in Fibonacci, we can store the values. So as we stored the values of suppose f of 1 to calculated f of 2, similarly here we can store the value of n comma k values, so that we if we have pre-calculated 3 comma 1, then we do not again call function for 3 comma 1 and use the value pre-calculated, and do not like run the whole code to find the values. Also the base conditions we know, if k is 0 or k is n, that means if nc0, we know that we are selecting 0 terms from the n terms, so there is only one way that we do not take any terms. If we have to select n terms from n terms, so there is only one way of taking all the terms, which is also number of ways as 1. So these are the base two conditions. Always remember to use base conditions, because otherwise it will go in an infinite loop. So always while writing a recursive code, just remember to uh, analyze the base conditions, and always do not miss any base conditions while writing any recursive code. So let's see the binomial coefficient code using recursion. So we write these two base conditions. So as we saw, if we know that k cannot be greater than n. If we have nck, we always know the n should be greater than k or equal to k, but n cannot be greater than k. Suppose it cannot be 2c3, because we just have two terms and we cannot select three from only two terms. So k should be always less than or equal to n. So our base condition becomes, if k is greater than n, uh, that means there are no zero ways to select k terms from those n terms. So we will return 0. This is our first base condition. Now our second base condition, as we discussed, is if k is 0 or if k is n, then the number of ways are 1. So if k is 0 or k is n, will return 1. So these are the base two conditions. Now we will calculate for the other values. Like if we have suppose 5c2, so we will call binomial coefficient of n minus 1 comma k minus 1 from this equation, and we'll call for n minus 1 comma k. So we'll return binomial coefficient of n minus 1 comma k minus 1 plus binomial coefficient of n minus 1 comma k. So these two recursive calls will do just like we saw in the recursive tree. 5 comma 1 will call for 4 comma 1 comma 4 comma 2, and so on. The tree will go on till we reach all the base conditions which will return the values. So the time complexity is, again, as we are making two recursive calls, so the time complexity will be exponential, which will be 2 to the power n upon square root of. So how can we optimize it? So DP help us to optimize these type of recursive codes, because we can store these values just like we can store 3 comma 1, which is again and again calculated 2 comma 1. So we'll store all the values so that we do not calculate again and again the values which are used multiple times. So as there are two values in the parameters which are changing, so we will take a 2D array which will be of size n plus 1 cross k plus 1, because for each n we can have k terms. Like for 5c2 we can have for each n k terms. Like for this will be a 2D matrix. For every n, suppose n is 1 and 2, and the k will go from 0 to k plus 1. So 0, 1, 2, and let's take it to n will be 3 and k. So like we will store the values as 0 comma 0 will have the value of n c k. So n will be the ith index and k will be the jth index. So 0 comma 0 will store the value of n 0 c 0. 0 comma 1 will store 0 1, but it will be 0 because we can't select one term from 0 terms. 1 comma 0 will store the value of 1c0. Similarly, 1 comma 1 will store the value of 1c1, and so on. So it will store the values of I, C, J. I and J are the loop variables which we are taking, which will represent the index of the matrix. I will represent the row and J will represent the column. So initially we will run the loop from 0 to I equal to n. So we will, if n is 3, we'll run to third index, and J will go from 0 to minimum of I comma k. Why minimum of I comma k? Because if our I, that means our row is suppose 2. So we can't calculate 2 comma 3. Our k is the, like, we cannot have k greater than, we cannot have the jth index greater than the ith index. As we saw, like in the nck, k should always be less than or equal to n. So we took this condition of minimum of I comma k. Suppose at row 1 we can't calculate 1 comma 2, because 1c2 is not a valid term, it will be 0. So as our array is initialized to 0, so we do not need to calculate that term. So it will be by default 0 only. So we will just calculate for the terms where the jth index, that means the in the IC j, we know that j should be always less than j should be always less than I or equal to I. So our j will go from minimum of I, or it cannot exceed k. As we know that we are calculate for nck, so we do not need to calculate for k plus 1, because we are just using the values of, we are just decreasing k, or equal, the k is equal. We are never increasing k, so we do not need to calculate for any k value which is greater than the given k. So here also we will write the base conditions, which will be if j is 0 or j is equal to I, that means I j is 0. So 1c0, 2c0, 3c0, every of these terms will be equal to 1, because to select 0 terms from I terms is always 1. Similarly, if j is equal to I, that means 1c1, 2c2, 3c3, these all terms will also be 1, because there is only one way to calculate, to find uh, n, like j terms from the I terms. Otherwise, this was only the base condition, because we just saw for if j is 0 or j is equal to I. But for the other terms, just like 1c0, we need to calculate from the equation which we had, which was this equation. So we can write this in the form of an, we can pre-use the values of an array. So we will, so the I comma j term will be I minus 1 comma j minus 1. Similar as we saw, like n comma k was n minus 1 comma k minus 1. So this is the first term, and then we will add I minus 1 comma j, so which was n minus 1 comma k. So in just two nested loops, we can calculate all the terms from to nck. Uh, in the recursive function, it was taking exponential time complexity, but if we reuse the values which we calculated previously, because we are just moving from 0c0, 0c1, only every element is traversed once, and we never, like in this we are again calculated 3 comma 1, but as we are using an array, so 3 comma 1 will be calculated only once, because this is a loop. So we do again, so our time complexity will be number of rows into number of columns, because this is a nested loop. So first loop will run from till n times, and second loop will run maximum of k times. So our complexity will be n cross k. So we have reduced our complexity from exponential to just n cross k. So this is how the DP help us to optimize our solutions, and always firstly try to understand the recursive code, and then try to use any space complexity to like store the values, so that we do not again and again calculate same values through a recursive code, and store those values to find the next value, so that our time complexity becomes optimal. So in all these questions we did, we always first always try to first understand the problem, write the recursive code, and then use some space or uh, some variables to store the pre-calculated values, so that we do not call the values again, function again and again to calculate the same values. So let's move on to some higher level question. This is a knapsack question. So if there are any doubts, please convey. Moderators, are there any questions in the chat box?
No, ma'am. There is no question. You can continue.
Okay. Everybody, if you have any problem like how the recursive how we convert the recursive to the optimal solution, or any questions if you have, you can ask. So let's move on to a question which is known as knapsack. It is a very commonly asked question by many companies, by many return tests. So in this question, we have a bag which has a maximum weight of W. Just suppose, consider a bag, a school backpack, and we have maximum W weight which we can put it into. So we have some items, n items, which have weights and corresponding values. So in this we have three values, three items. So first item has weight 10, second item has weight 20, and third item has weight 30. So every item has a value associated with it. So the item with 10 kg has the weight of 60, item with weight 20 as the value of 100, and item with weight 30 as the value of 120. And we have the total weight as 50. So we have a bag which can hold the capacity of maximum 50 kgs, and we have these three items which we can use to fill this bag, and we need to maximize the values. So there are many ways to fill the bag, and you can also fill the bag with less than the weight capacity, but you cannot exceed because the bag can hold maximum of W weight. So if we just put the first item which has weight 10, then we will get the value 60. But we can get a better solution, we can get a better value. We just need to maximize the value to fill our bag. So if we have the weight as 20, we place this item which has the value of 100. So we'll have value 100. Similarly, if we just place the third value, we will have 120. But we have capacity of 50. So we can put multiple items, because if they do not exceed the total weight of a knapsack. So if our weight is 20, if we place the first two items, weight with 10 and 20, so we'll have 100 plus 60. These two values will be added because we put these two items. So we will have 160, which is greater than all of these. So we'll similarly check for all the ways in which we can put the items into the bag and get the maximum value into our bag. So we can see we can place 30 plus 20 in the bag and get the maximum value as 120 plus 100, which is 220. But if we place all the three weight, but it is not possible because it will exceed our maximum capacity of our bag. So we need to find all ways in which the bag can contain the items which whose total sum will be less than weight or equal to weight. So let's see the choice diagram. So choice diagram is just like basic understanding how we uh, how our, how our weights and the items can go into the bag. So let's take a item which has weight W1. So if that weight is less than the capacity left in our bag, which is W. Suppose we have a 10 kg bag, we already put an item with 2 kg, we have now 8 kgs, and our current item has weight of suppose 4 kgs. So we can either take that item, or either we will not take and take some other values, because that item is not maximizing our result. So we have two cases. If the weight is less than the W, that means the the left capacity of the bag is less than the weight of the current item which we are considering to put it in the bag. So there are two conditions: we can take the bag, or we will not. We will take the item, or we will not take the item. But if the weight is greater than W, suppose we have 5 kg capacity left to put it in the bag, but our item is of 10 kgs. So we cannot put that item because it will exceed the total capacity of our bag. So we will check the condition. If the weight is greater than the value is greater than the weight of the item, then we cannot take simply, and this item will not be taken, and we will move further to the next items. But if the weight is less than the capacity, then we will consider two cases of taking the item or of not taking the item. So if we understand this basic condition, then it is very easy to write the code. So firstly, we will see the base condition. So what is base condition? So if there are zero items, that means n is double equal to 0. So we do not have any items left, or if there are no items, then we cannot place any item into the bag, and just the profit of not placing any item will be 0 because we are not adding any weight which do not have any value. So our profit is 0, our value is 0. Also, if the weight is 0, if we cannot place any item, the bag is full and the weight left is 0. So we will return 0 because we cannot add any item. So the profit will be 0. So these two are the base conditions. So, so we have all these are the parameters: the weight array, the value array, W is the total weight of the bag, and N is the size of the array. So we are reducing N and W. Why? Because N will represent the index of the item which we are considering to take in a bag, and W is the weight left. So initially we will pass the total weight. If we take any weight, suppose I have a bag of 10 kgs and I already put a 2 kg weight in that. So my capacity will now be 8 kgs because 2 is already filled. So I will reduce W to the capacity left, and N will be my index which I am considering to of the item which I will take or not take. So if my N is 0 or W is 0, that means I do not have any item or my weight is already full. So I will return 0 because from this function we will return the profit. So as we discussed in the choice diagram, we have two conditions. That the weight is less than or equal to the total weight, or it is greater than the total weight. So here we write if the weight of the n minus 1 term. So if there are suppose five terms, let's take this example only, 3 terms. So first we will check for this weight, this item, and if this weight is greater than the total capacity, which is 50, it is not. If suppose it was 60, so we cannot take this weight, and we will just return the profit which we receive from these weights to put it into the bag. So we will just return knapsack of W as the weight remains same, as we are not placing any item into the bag, and the n will reduce to n minus 1. So now we have considered for the n minus 1th term and passing to the function n minus 1, which will indicate that the nth term is taken, and we just need to calculate the value for the previous n minus 1 terms. So this was the first condition. Else, we saw there were two ways, and we need to find the maximum profit which we will get from all the items by putting them into the bag. So if we take or not take, so there are two ways. So we will take the maximum value and return, because we need the maximum to place all the items. So there will be two cases. So first, if we take the item, the value will be added, because whenever if I put a item into the bag, the value increases. So our value will be value of n minus 1, because we are considering the n minus 1th term. So we take the n minus 1 term. So our value will be value of n minus 1 plus the number of ways to calculate to put the items into the bag, where my weight is reduced to w minus weight of n minus 1, because in our bag, which was having capacity w, I have already put some weight which is having weight wt of n minus 1. So my weight is reduced to w minus wt of n minus 1, and also my n is decreased to n minus 1, because I have taken the n minus 1 term, and now I'm telling the function to just check for the previous terms, which are n minus 1 terms. And this was a condition where we were taking the value. Now we will take the condition where we will not take the that particular weight. So that will be knapsack of w, because we are not putting any value, any weight to it. So weight will be similar, which was initially w, which we passed to the function. And as we are not taking, so that item is already discarded. We discarded that value, that we will not take it. So our number of items get reduced to n minus 1. So here it was n. Suppose I had 5 values. So in every recursive function, I decrease my n. If my n was not decreasing, then it might go to infinite loop. So always keep in mind to decrease the variables which are changing in the recursive function. So here also we had w comma n minus 1. Here we had, and here we had this weight comma n minus 1. And we are taking the maximum of both the conditions of taking the weight and not taking the weight. So this was the recursive code, but uh, you can notice that we are uh, again facing the problem of calculating the same terms again and again, because for n minus 1 we are uh, we are calculating many values w comma wt of n minus 1, and as we saw in the recursive tree, uh, as there are two function calls, so there will be collisions, and store these values in an array, so our time complexity will get reduced. So let's do it with the DP approach. So as we have learned till now that in DP, if we use a extra space, or whenever we have uh, multiple function call with the same values, we can store it into an array and reuse it if it is recalculated. So here two variables are changing, w and n. So we will create a 2D matrix, because there are two values which are changing. So for every n, there will be w variables. Suppose we have 1 1 1, each weight has weight 1 and different values. So for every n, we have w different weights. So we will create a 2D matrix of n cross w, n plus 1 cross w, because 0 is not our case, and for n comma w we have the value to calculate for w weight and n items. So similarly, like we did, we will take two loops. First loop will go iterate the rows till n, and the second loop will have the values till w, the total weight which we have. And in the array we will store, like if I is equal to 0 or w is equal to 0, this is the base condition. That means if I is 0, that means we do not have any weight. We learned that if n is 0, then the value is 0, because we do not have any item to place. Or if w is 0, W is our row. That means our total capacity of the bag empty. So if W is 0 or there are no items, then the array will hold 0 value. Else, we studied in the choice diagram as two conditions, that weight of I minus 1 is less than equal to W. That means we have two conditions. Either we will take the item or will not take the item. So we'll calculate the max of these two values. Uh, if we are taking the weight, then it will be value of I minus 1, because we are considering the item I minus 1 in this row. In every row, we are considering the item I minus 1. So we will add the value I minus 1 plus the maximum value, which will be held by k of I minus 1 and w comma wt of I minus 1. That means uh, if the capacity is W minus WT of I minus 1 and there are just I minus 1 items. So we'll calculate this if we are taking the item, and K of I minus 1 comma W. That means the weight is same and the items get reduced by 1. So we'll find the maximum of these two things and it will be stored in I comma W. So what is I comma W holding? So I comma W is holding if we have the first I terms and the weight is W, then what is the maximum value which we can get from these initial I terms and total if the bag capacity is W. So that whenever we call again and again the function, we have the values in the K array and we do not call again and again for the same values. So this was our condition where the weight is less than the capacity. But if it exceeds the capacity, then we cannot take that item. So it will be just I minus 1 comma W. We are just discarding that item and uh, the maximum value will be taking that total weight as W and I minus 1 item, and we'll just assign I comma W to K minus 1 comma W, and our final array will store all the values. So we need to return the value if we have all the n items, so which will be stored in the last row, nth row, and wth column, the last column. This was the mat which hold the values from rows was 0 to n, and columns from 0 to w. So n comma w index of the 2D matrix will hold the value of taking the knapsack with all the items in consideration and total weight as W. So we'll return this. And our time complexity got reduced because in this we were calling again and again recursive function which gave us exponential time complexity. But here we are just running two loops and the operations inside it is just of O of one operation. So our time complexity will be O of n cross W. So we reduce the time complexity from exponential to just n cross W. So are there any doubts, moderators?
Till now, there is no doubt. If anyone is having any doubts, you can put them down in the chat box.
Everybody, please feel free to ask questions. So these are some references you can refer to. This is a Geeks for Geeks has the best. Like you will have all the theory and also the questions. So you can go through this. These are the practice links, and these are the two YouTube playlist links which you can refer to. Thank you.
On behalf of Creators Garage and Computer Club, I would like to thank our instructor, Ms. Saniya Agrawal, for investing her precious time on our participants and sharing her precious knowledge. It was a wonderful session And we also thank our participants for being such an incredible listeners. All of you are requested to fill the feedback form. Otherwise, you will not be getting your certies. Guys, link for feedback form is in the chat box. Kindly fill it. Thank you, ma'am, once again.
Uh, are there any doubts or anything?
No, there are no doubts.
Okay, no problem. I hope you got to learn from this session. DP is not a very difficult topic. Just all the best and thank you for having me.
Thank you, ma'am, for being such a good instructor for all of us.